All right, class, welcome to this quick video on the selection sort algorithm. This is the first of several sorting algorithms that we are going to go through, and this is probably the simplest. We're also going to find out it's the slowest, but it does work, so let's get into it and take a look at what we need to do for this algorithm. So selection sort is what we're doing today. I have set up this integer array called R, and we're going to use this as our example in how to sort. So let's discuss the algorithm in simple form first. Let's talk about what we need to do. So the first thing that we're going to do in the selection sort is we are going to, of course, loop through the array. So we're going to loop through the array looking at each item one at a time. So I'm going to take that first item and I'm going to essentially pull it out of the array. I'm going to use that position and I'm going to compare it to each successive item in the array. So let's take a look at each item coming down the list here. So I would look then, and I would compare this first item 5 with 2. And if 2 is less than 5, since we want to create an increasing list from small number to the next biggest number, I would swap my index with 5. So I would, use the correct tool here. I would swap this out. And this is essentially what would happen. And I would compare this to the next one. 2 is still smaller than 3. 2 is still smaller than 6. 2 is still smaller than 4. So I'm working my way through. Then 4. And then finally, I would compare 2 with 1. 2 is smaller than 1. And I would swap these out. Now that I'm at the end of the list, I finally can place 1 at the beginning and start the process over. So then everything shifts over, and I now look at this. I pull out my 5, and I compare once again. Is 5 smaller than 3? No, it's not. So 3 comes out. 3 is smaller than 6. 3 is smaller than 4. 3 is not smaller than 2. 3 gets swapped with 2. And we move in here. Now this is a simplification of the algorithm. We don't actually do those swaps in the middle of the algorithm. We actually wait until the very end to do our swaps. So let's write that down really quick. So what we do is we take a successive item in the list. So take each item in the list or array. Let me clean this up so you can see it. And we compare it to the other items. To each item after it, I should say. We're going to save the index of the smallest item found. And finally, once we're at the end of the list, we are going to swap our item for the smallest one found. And we're going to do this for each and every index. So we're going to take each item one at a time and compare them as we move through. So let me go ahead and reset this here. Hopefully I can remember what the order was. The one I know was at the end. See here, this was there. I think that's out of order enough. We can use that for example as we do our code. Okay, so we're going to continue to use this R as our array, and we're going to do this algorithm with an array. not an array list. We're going to work with this as an array. Okay, so take each item. Take each item should instantly tell us we're going to need a for loop. So we're going to take a for loop, and we're going to go one item at a time. And because we're doing swaps here, we're going to need to know the placing of each item. So we're going to need the indexes. So we're going to have to use a standard for loop. So int x equals 0. And we're going to say x less than r dot length. And then we're going to have our x plus plus, you know, our standard for loop here. Okay, so this is our standard for loop as it stands. And what do we need to do? Well, we're going to need to compare this value to each item within our list here. So we need to compare the item, and we need to save the index. So we're going to need something to save that index. Okay, so let's first create something to save that index, because we're going to need it a little bit later. So int, we can call this min ind, that's an I, and we'll set that to our current index x, right? So we're assuming that our current index is the minimum value index. We're assuming it's in order. Okay, and now we need to compare our x value, right? We've pulled out x at 5 here, perhaps. We're starting at 0. We now need to compare it to every other item in the list. So we need another loop that goes all the way through the list, or in this case, the array. So we need another for loop. And our for loop is going to compare every item after this, because we're going to assume that our algorithm has worked properly and everything in front of it is properly sorted. So we're going to say int let's call it int y, just for my handwriting here. Int y equals x plus 1. So y is going to start at the next index value. And we're going to assume that we have y less than r dot length and y plus plus. Okay, so now we do a simple search. We've done our linear search. This is what we're doing. We're doing a linear search inside of our loop here that's just going to find the smallest value. That's all that we're doing. So we need a quick if statement in here. Move this down. We need a quick control statement that says if our position y, so if we're looping through and we find something smaller than our x position, 5, so if we find something smaller than our x position, save that index value. Remember where that smaller thing was so that we can use it later. So we're going to loop through, and whatever's smaller than our current value, we're going to save it here. So what we're going to do here is we're going to look at, and we're going to change something up here. We're going to look at that minimum index, right? Our minimum index is, in fact, x. And we want to compare not just is this value that we're looking at smaller than 5, is it smaller than the previously small value that we found? And we know the previously small value is going to be our min ind, right? Our minimum index. So if our array, let me get better handwriting here. If our array at y is smaller than our array value at minimum index, well, then that means that y is smaller than minimum index, and index isn't actually the smallest value we found, so we need to set our minimum index to our new y value. So minimum index now gets our y value. Okay. So we loop through, we say, hey, we think that this next value might be the smallest one. We set our minimum index value to that, and then we go through and we check, is this the smallest value? Is this the smallest value? We keep resetting which one is the smallest value. Now we still have this x value sitting here. We're still inside this loop. So what we do is once we've found this smallest value, once we've determined which one is our minimum index, we now can come back and use our x value here to swap our minimum index and our x. So we know our swapping algorithm. So our swapping algorithm is real simple. Remember, it takes 3 lines of code. First line of code is we need to create a temporary location. So let's go ahead and swap it this way. So int temp. Remember, we're still inside the outer for loop. Int temp is going to get the value at array of minimum index. So we're going to save that into a location. So now minimum index is protected, whatever the value was at minimum index. And now we can save the value that was at x into minimum index. So array at min index gets the value of what we were searching through, right? So if we had 5, we found 1 was it. Our x is still 5. So we need to swap our 1 and our 5. We need to swap 1 and 5 here, okay? So we've saved this value into min index. And now what we're going to do is we're going to copy 5 into this position and then put min index back into index 0. Okay, so our min index gets the value that we have at r of x. And r of x, or r at x, gets the value of temp. Now that we've done all that, we can close our for loop. We have done everything that we need at that index. We move on to the next one. We increment x by 1. We move to the next position. 5 and 1 have now been swapped. We now pull out 2. We're at index 1, and we repeat the process over and over all the way through the end of the list. So this is selection sort. Let's do really quick big O notation analysis on this. So our last lines of code here, these are all O of 1. So those are all O of 1. Our if statement and our check here, this is also O of 1. But this is inside of a for loop that in its longest iteration is going to be O of n. Because remember, we want to look at the longest case. The longest case here is going to be O of n, and O of n minus 1, but again, we don't care about small numbers in big O analysis, so O of n is what it's going to be at. And this is inside of another O of n loop, which means we're going to have multiplication. So let's compile all of this down here, and we're going to have 1, 2, 3, 3 times O of 1, and we're going to have, this is going to add to, since it's after, it's not inside, it's going to add to our O of n times O of n, which is also times O of 1, because our O of 1 is sitting in the middle there. So we have 3 O of 3, which we don't care about. It's too small, right? If we're talking about 1,000,000 items, running our program 3 times, 3 operations, doesn't really matter if our array size is 1,000,000 or 1,000,000,000. So this gets destroyed. Again, with the O of 1 inside of here. If our arrays are millions and billions in size, this doesn't matter. All that matters is the O of n's here. We multiply the inner terms, and this algorithm is O of n squared. So not very fast. When we learn some of our more complex searching algorithms, we're going to begin to get this O of n down, and we're going to begin to approach O of n. We won't get there, but we're going to begin to approach those values. So O of n squared, not the fastest sorting algorithm, but still a very reliable and easy to understand sorting algorithm. All right, I will see you in the next one where we talk about insertion sorts. See you in the next one.